Okay, so in the previous video, we left off with the average. Now we're going to design two functions, one for max and one for min. Basically, they will return a double type that will represent either the maximum value or the minimum value within the set of numbers stored in the array. So, to do this, we would like to be able to display not only the average, but also the minimum and the maximum. So these will be the variables that I'm going to need to display when I'm done, okay, in addition to average, in addition to displaying the whole array. So it will give me a good picture of what's going on in the array, okay? All right. So we need to design the function, let's say, for maximum. Let's start with that. So let's prototype this. Double max, let's call it max, okay? And then notice I'm going to keep it consistent. And then comma, int. And then semicolon. This function will return the max value stored in the array. So that's the idea behind this, okay? So when are we going to call it? We're going to call it right here, right after we've done average, before average. It doesn't matter as long as you do it after you've entered the data in the array. So you cannot call max or min when we're ready to do min before you've inserted the data in the array. So this has to come first, data in. Now you could do average, min, max. So in my case, maximum will be equal to max. And I'm going to keep it consistent, my array. And then guess what? AR, this time we'll not make that mistake we did before. We're going to use a local variable for size within function main. Now let's go ahead and define this function. So that's the strategy. This is what we want to do. And we will eventually want to print the, so let's put a report here, so /n, and do maximum equals, and that would be maximum. And let's do also the same thing for minimum. So this will display a nice little report for us when we're ready. And that would be minimum and end the line there, okay? So for min, the same way, okay? So we're going to we use the same strategy. Well, let's focus on maximum right now. So for maximum, double. Now you could copy the whole signature here, paste it here, and formalize it, and keep it consistent with what we've done before. So AR PTR and int size. Let's open curly brace and close curly brace. Okay. So now, how do we evaluate for maximum within an array? Well, the best way to do this is to create a temporary variable that's equal to the first element of the array. And then from that point, you compare that one to the next element, then the next one to the next one. Okay? So let's call that element high or highest. Let's call it this way, double highest. And right from the get-go, make it equal to the first element that comes out of that you could dereference from the pointer. So we now know that if you did this, the variable highest will have the value of the first element of the array. Now we can compare that to the next element, the next element, and the next element. So we could do this in a loop. And as long as highest is less than the next element, you do nothing. If it is greater, then swap. Okay, so now we have an algorithm in place. At the end, you're going to return the highest. That's the key here. Okay, so we're going to do something here with a loop. Now remember, our highest is already equal to the first element. So there is no reason to compare with the first element of the array. You need to move on to the next one. Okay, so how do you do that? So we could do something like this. One thing you could do is move the pointer at least here. Okay, so AAR PTR plus plus. So now the pointer is moved to the next element. And what you're going to do here is int I equals, let's say you want to skip. You just want to count up to a certain point. You could start at 1, right? Now, this is not an index. You're just simply, instead of starting at 0 up to max, or to the size, right? You're starting at 1, so you will always have less iterations. So you could do something like this, I less than size. Okay? You could do something like this, or you could do 0, but make sure your size is subtract 1. Otherwise, you're going to be comparing to an element outside the array. So as long as I is less than size minus 1, and then I plus plus. Okay? Remember, and the reason for this is that you've already pointed to the first element and made highest equal to the first element in the array. What I need to do now is compare highest to the next element. So, if highest is less than asterisk, AAR, PTR, so whatever data you're pointing at now, then swap it. Then what you need to do here is you need to swap, which means you're going to make highest equals that value. And no need for it else means if it's not true, don't do anything. Okay? So that's how you're going to be able to switch or change the value for highest as long as you're stepping through the array in this manner. Now let's see if this works for, so what I'm going to do here is I'm going to put since we're not calling minimum, and I'm just going to put a semicolon here for the display. Since we're going to call max and see how it works. So I'm not calling min, I haven't defined min, so let's go ahead and try this. Okay, so compile and run. Let's see, I'm missing, I forgot to do one more thing. Semicolon, and while I'm in the for loop, I need to increment the pointer, which is a good thing. It's a good thing I've missed that semicolon, but it's telling me also logically that nothing is going on here. You need to move the pointer. AR, PTR, plus plus, otherwise you're going to be stuck. Now notice the if statement is a single line of code, so no need for curly brace. This AR, PTR, plus plus belongs to the for loop. Okay, it does not belong to the if statement. So regardless of what the if statement outcome is, you will still increment the pointer here. All right, let's compile and run here. And let's put some data. So I've got 45. Let's make this one the highest. And then 2, minus 2, and 0. And notice the maximum is 100. Okay, so it picked up on the highest. Let's run it again. So a lot of times you want to do code testing. You could automate this, by the way. Let's suppose now I make this one the highest, 110, and then the rest are something like this. Let's see what happens. And it picks it up. Now let's go ahead and make the highest the last element. Okay, so you're always stretching and measuring and seeing how things work. And this is good practice because you don't want to submit your code as a working product. Let's put a -3 here, 12, 6, and 100 as the last element. Okay, and it picks it up. So the average was 24.8, the maximum was 100. Now, for the min, the algorithm is pretty much the same. Okay, so notice this algorithm, how we developed it. So for the min, it's not any different. All right, well, let's work out on the min. So for the min, we're going to need a double, min, double, and stay consistent with your code. And then an int here, put a semicolon. And this will return the min value stored in the array. Okay, so this time I want to display minimum. Take that semicolon out of here. Oops, got the wrong thing here. And call minimum equals min and send my array to it. And then the R size there. Okay, so you can see the code now is very consistent. And we're going to do the min here. So watch what I'm going to do. I'm going to cheat. Actually, the concept is exactly the same. So I'm going to copy this. Okay, and I'm going to go over here, paste it, and call this one min. And this one, call it lowest. Okay, so just work the logic. And as long as lowest is greater than, if it is, swap lowest. And then all you're doing, so you flip the logic, and all you're doing is replace highest by lowest. That's it. Okay? Code made easy. Once you understand the algorithm, how it's supposed to work, which means you created a lowest temporary variable, you made it equal to the first element of the array, you moved the pointer to the next element, you adjusted your loop to go one less than what it would have gone, let's say if you were printing the whole content of the array. Okay? So that means because that's all you have. You've already compared to one item. You've already assigned to one item. So you're comparing the first element to the rest of them. So let's go ahead and see if the lowest will work. So let's compile and run. And let's see here. I got an extra. There you go. Compile and run. And there you go. All right, so we're going to put a 23. Let's do a 45 as my highest. Let's put a -3 as my lowest. And let's put a 10 here. And a 1.1 or 1.2, if you will, right here. And sure enough, max is 45, min is -3. Now, what you can do once you copy this code and rewrite it for yourself, go ahead and test it out.